2.3, Introduction to Functions. What a function is, it is a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. What this really means is that the first variable is paired with exactly one of the second variable. When we're talking about points, what's my first variable called? We're talking about data points. X, the second ones are y's. For every x, there can only be one y. Domain. When talking about functions, do you know what domain is? You forget. None of this should be new. All of you took Algebra 1. Domain is all of the first variables, your x values. What's the other one called? Domain and range. Range are all of my y values. So for every domain, there can only be one range. I have this set of numbers. The domain are all my x values. So I have 2, 4, 6, 8, 10, 3, 5. The range are all my y values. 2, 3, 4, 5, 6, 3, 1. I need you to write this table down. Looking at this set of numbers, we need to look at the domain. For every domain value, there can only be one y. Does 2 repeat? We're only looking at the domain. Does 2 repeat? 4, or 6, 8, 10, 3, or 5. None of my domain repeat. This is a function. I look at the domain. None of the domain values repeat. It is a function. Here's another set of numbers I want you to write down. All right, looking at this set of numbers, does 3 repeat? No. 3 and negative 3 are different numbers. 4 repeat? No. 5. So I have 5, and I have 5. 5 goes to 4, and 5 goes to 1. Think of it like a classroom schedule. 5th period, you have to go to room 4, but also 5th period, you have to go to room 1. Impossible. You can't do it. This is not a function. That's when I look. On this one, I didn't look at the range. Because 2nd period, I'm in room 2. 4th period, room 3. 6th period, room 4. 8th period, room 5. And so on. I'm fine. I'm in a different classroom. Yes, I might go back to room 3. But that's fine. I can't be in 2 places at once. Now, if I actually took right there, why is that a function? It's the same thing. 5 goes to 4, and 5 goes to 4. So once I look at because I had a repeat, it's going to the same number, I'm fine. It's actually the same thing. If you look at your schedule you have, did everyone's schedule say 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th? Did any of them repeat? Yeah, some of them had repeat for the AB class. Like this class, it might have said something twice. Still the same classroom, just written differently. It's a repeat. Do you understand when it's a function, when it's not a function? All right. So because 5 went to 4 and 5 went to 1, it wasn't a function. The other way you're going to see it is instead of in table form, is like this. You just need to look. I just need to look right there. Do any of my x values repeat? Yes, I have my 5s. They repeat, so it wasn't a function. Most of the time, you're going to see the data sets like this. You're not always, though, going to see visual numbers. Sometimes you're going to have to see it with graphs. We use what's called the vertical line test. If every vertical line intersects a given graph at no more than 1 point, then the graph represents a function. All right, I have two graphs. Let me explain what this is. Let me just draw a graph. There's a graph. I'm going to take a vertical line. Now, the best thing I have for a vertical line is my pencil. So make this yellow. There's my pencil. You take your pencil on the paper, on the calculator, and that's my vertical line. If I take the vertical line, does it ever cross my graph more than once? Where? Right here? It never crosses more. Actually, down here. There. It never crosses more than once. This is a function. Let me show you an example of one that's not a function. If I take this here, does it ever cross more than once? Everywhere, right? I have a point here, and I have a point here. If I look right here, at 1, it's 1, 2, 3, 4, 5, 6. At 1, it's 6, and at 1, it's also 1, 2, 3, 4, down to -4. How could 1 be 6 and -4? That's why it's not a function. So functions, if you take your pencil, should only cross more than once. No more than once. And it has to be continuous also. Yeah, you can't connect back to the original spot. Or, I mean, even this right here, that's not a function. Because right here, the vertical line test will fail. Right. I have this right here. I want to know the domain, I want to know the range, and I want to know what the function, if it's a function. So copy this down first. Looking at these, my domain. My domain are all of my x values. What are my x values? What's my x value here? It's not 1. So it's -6, -4, -1, and 1. That is my domain. It's all the x values. What about my range? 1, 2, 3, 4, 5, 6, 7, 6, 4, 2. Is this a function? Do any of my x values repeat? No, none of the x values repeat, and I can look. There's no repeats on a vertical line test. It is a function. This is called a discrete function. A discrete function is a graph of individual points. Here's this one. For this one, I want to know the domain, the range, and the function. This one looks a little bit different. Now, what do you notice about this? It's just a straight line. So the domain, yeah, you don't know where to start. It's not just that point. What's the smallest the domain ever gets? What's the smallest to ever get on my axis? Nope. Nope. -4. But then what happens after -4? It goes on, goes on, goes on. Will it ever stop? Why won't it stop? It has the arrow. So the domain are my x values. And all of them have to be greater than or equal to -4. Right, this is the way you're going to see most of these. x is greater than or equal to negative 4. Right. Because it's telling me that's at negative 4 and it goes on forever. Some people are going to go negative 4, negative 3, negative 2 until you get up to here. You have to remember, you just don't have these points. There's also a point right here. So it's like negative 3.5. You still have fractional points. It's everything in between there. What about my range now? Y is greater than or equal to negative 2. Why is it greater than? It starts low and then it goes up. All the y values are getting bigger as I just moved everything. Is that it right there? Yeah. It starts at negative 2 and everything's above it. Is this a function? Can I take and draw straight lines and never connect? Yes, this is a function. This is called a continuous function. A continuous function, you're going to have a ray, a line, a segment, or a smooth curve. We're going to be dealing with a lot of these. For functions and function notation, we're going to be talking about an equation. We've been dealing with equations that are y equals. An equation is just a function. Instead of writing y equals 2x plus 5, we're going to write f of x equals 2x plus 5. That f and then the x in parentheses, you say f of x. It is a function of x. X is called the independent variable. F of x is called the dependent variable. Back in Algebra 1, x was the independent variable, y was the dependent variable. F of x and y both depend on what x is. Don't make this more difficult than it needs be. Instead of writing y equals, you're going to write f of x equals. And then I want you to make this table. Looking at the table, this is the same exact thing as having x, y. Here's my x's. This would be my y values. How do I find my y values? If this was an x, y, and this was my function. If that's negative 2, how do I find out what 2 times negative 2? That's what you're doing, and you're going to get 1. That's all you're doing for f of x. You're saying f of negative 2. The function of negative 2 is 2 times negative 2 plus 5, which is 1. You're doing the exact same thing. Now, you did this in your head, right? By looking at this, what's my x value? Negative 2. Where are you getting that from? Well, if I didn't have this, it comes from this. So when I do 0, it's f of 0 equals 2 times 0 plus 5, which is 5. F of 5. It's going to be 2 times 5 plus 5, which is 15. You're not going to need the third column. All you're going to have to do is go f of negative 2. You figure it out is 1. F of 0 is 5. F of f of 15 is equal, or not 15. F of 5 is equal to 15. What's my x value in this one? Negative 2, what's my y value really? 1. What's my x value? What's my y value? Do you understand how to read it? If you make a table to solve these, if I said solve from negative 5 to 5, you don't need the middle table. I just put the middle table there for you to see what I was talking about. Questions on this now? Does it make sense? All right. Open your books to page 947. 47.